Of course, we don't want the particles to continually emit. So first of all, I'm going to check in which frame the missile is contacting the terrain, and we will emit only on that single frame. So go back to the object context. For now, I'm going to disable all simulations. Make the missile visible and scroll up to around frame 26. So let's go with frame 26. So first of all, we don't need the solver to work before this frames, and we will also need to tell the source only to emit on this first simulation frame. So that should be straightforward. First of all, let's dive back in our snow avalanche node. Select the avalanche network, and under the simulation tab, change the start frame to 46. Now dive back in, select your source flip node, and we're going to look for the activation parameter. So currently the activation has a value of 1. This means that it will be continually activated during the whole simulation. So what I want to do is tell this value that it will only be active on the very first frame of the simulation. And we can do this with a simple expression. You can type $SF, which means simulation frames, equals 1, and then press enter. So what we are saying here is if the simulation frame is equals 1, or if we are on the first simulation frame, you should be on. Otherwise, you should be off. And we can confirm this by middle clicking this activation parameter. So notice now we're on frame 46, so the value is 1. If we move forward one frame, this will change to 0. Also, if we go back one frame, this will also be changed to a value of 0. So this means that the activation will be on only if we meet this condition. Okay, so let's take a look at what we have so far. Another thing that I want to do is change the visualization of the particles. So I will select my flip object, go into the Guides tab, find our Particles tab, and change the visualization to Particles. Okay, go back to frame 1, press play. Don't forget to turn back on the Enable Simulation button. Okay, and now we have only this sphere traveling through space. So now we only need to add the terrain as a collision. So this will create a splash and the rolling of the particles down the hill. So let's do that now. We did create some terrain collision geometry. So let's go back to our object context. Dive into the terrain collisions node. And here we can copy this null, select the out collision geo null, press Ctrl C, and then we can go back to our simulation, dive into the DOP network, and we will select our static object, and under the sub path we can press Ctrl V to paste this null output. The geometry is not deforming, so no need to turn this on. I will turn off the display for the geometry. Now let's go under the collision tab, turn on the collision guide, make sure that the collision mode is volume sample, and now all we have to do is here under our proxy volume, select the volume that we want to use as a collision proxy. So we can paste this same value and just change this suffix to vol. And if you're not sure, you can always select this node from the list and press enter. So here we have our collision back into our simulation. The resolution seems quite coarse, so I'm just going to check the resolution of our collision volume. Currently it's 0.8. We can bring this down. Let's try with 0.1. And let's go back to our simulation. Okay, so now I'm back after my Houdini crashed. I did revert my volume resolution to 0.8. Apparently 0.1 was too much. The simulation is quite slow, so we may have to reduce the particle separation for now. I'm going to bring it down to 0.1, and I will also reduce the resolution for our flip source. So let's go back. Select the flip source node, and I will change the voxel size to 0.2. Same for the particle separation. And we may revisit these values later. Let's just make sure we have everything working. So let's go back to our simulation. And let's make another test. Okay, so this is more like it. So let's take a look from the camera view. So of course this is a default simulation. First thing I'm seeing is that it's probably sliding too much. The particles currently feel as if they were on ice. Another thing is that I may need to increase the domain. And finally, I think I will also add some drag, probably even some noise to the particles, just so we have a more irregular distribution of the particles. So let's save the file and take care of these changes. So first of all, let's work on the domain. I will turn off the simulation for now. Select my flip solver. You can press enter on the viewport just to manually move this domain. I will bring it down, probably more to the left, and I think this should be enough. Now select your static object. Let's actually change its name to collision terrain, and let's take a look at its physical properties. My guess is the friction is too low, and it's actually not bad. Let's increase it just a bit. I'll go with 4. And take a look at our flip objects. Probably we want to check the particles instead. So go to the physical tab. And I think this is the problem. The friction is 0. Let's increase this to 0.2. And let's try now. Don't forget to turn on your enable simulations. Press play. Okay, so I think this is much better. Let's just add a little bit of drag and probably a little bit more of friction. So let's increase this value to 0.8. And I will also add some pop forces. So let's add a merge. We've done this before. Connect the merge to the second input, the particle velocities. And let's add a pop drag. Let's change the value to 0.25. And let's make another test. Okay, so now we're containing much more this splash. Of course, it will slide much slower, which is fine. I think usually the snow doesn't react as fast as the water. One thing is it still seems a bit too uniform. So let's add a pop force with some noise. And perhaps we can also add some variation to the initial velocity. So let's do that first. Let's go back to our source. Select our point velocity. And under the curl noise, let's turn on curl noise and increase the scale a lot. Let's go with 20. Remember, the scale of this scene is quite high. We have a huge mountain and the emitter is quite big as well. So let's go with this for now. Dive back into your DOP network. If you want to reset your current simulation, you can control click on this button, disable simulations, and press play. I think we can go with this. Let's just add this pop force we mentioned before. So type tab, then pop force. I will connect this force to the merge node and call it turbulence. And here under the noise amplitude, let's increase this value. Let's start with 2. Let's leave the rest as it is. And let's make another test. So I will control click on the brain button and press play. Okay, so I'm liking this result much more. So what I'm going to do now is, as usual, I will increase the resolution of the simulation and create a flipbook. So go back to your first frame of the simulation. Select your flip object. And let's decrease the particle separation. I'll go with 0.04. And let's channel reference this value to our source. So right click on the particle separation, copy this parameter, go back to your source, and paste the value under the voxel size as a relative reference. Same for the particle separation. Paste as a relative reference. Again, let's go back to our DOP network. And this time I will create a flipbook and come back in a moment.